Dear students, good morning to all of you. I am Dr. Dinesh Kumar, Principal Scientist, Division of Agronomy, IERI, New Delhi. And today is, of course, Saturday, second Saturday, 10th September 2022. Time is 11 a.m. And we continue to discuss essential plant nutrients. We started with their classification and tried to understand two kinds of classification. One was based upon um, their relative quantity taken up by plant or required by plant. Other classification was based upon functional role of nutrients. That was by Mangel and Kirkby. And then we studied nitrogen, role of nitrogen deficiency symptoms and occurrence and how to correct the nitrogen deficiency. Then we came to phosphorus, potassium, their major roles in crops or plants and occurrence of deficiency and causes of deficiency and how to correct phosphorus and potassium deficiency. So in case of NPK, major nutrient, you need to supply nutrients through all the possible sources, including your biofertilizers. You know about TSD and nitrogen fixing biofertilizers are there. Organic manures, including green manure, farmyard manure, compost, vermicompost, even crop residues can be used as a source of nutrients. So for management of NPK, you need to go for integrated nutrient management. And if you follow integrated nutrient management, including biofertilizers and organic manures, then some of the micronutrients and sulfur are by default or automatically managed. You need not to manage them separately because their quantity of micronutrient is very small needed by the plant. And then we discussed in micronutrients. Micronutrients we started with the studied like iron, boron, etc. And some are left. So some of the micronutrients, that is zinc or nickel or copper, etc., we will discuss today. So we know about management of micronutrients. So management of micronutrients can be done by organic manures, particularly farmyard manure, green manure, and also by their salt. Salt is mostly sulfate salt. Sulfate salts are used for metallic micronutrients like zinc sulfate for zinc, iron sulfate for iron, or nickel sulfate for nickel, or copper sulfate for copper. Similarly, if you need cobalt, then you can use cobalt sulfate. So sulfates are used in case of micronutrient, and except zinc, other micronutrients can be fed foliarly also. Foliar fertilization can be done in case of many micronutrients because their quantity is very small, and sometimes in soil, if micronutrients are in excess, little bit excess, then they can become rather toxic to the plant. Toxicity of micronutrients can happen. Toxicity of zinc, toxicity of iron, aluminum. Of course, aluminum is not essential nutrient, but it is in the category of micronutrient, you can see. So aluminum, cobalt, these can be toxic under certain conditions. So therefore, sometimes soil application, if it is done, it should be done very carefully. Otherwise, you may end up with the micronutrient toxicity also. So foliar spray is suggested. In case of zinc, it is soil application. Soil application is preferred for management of zinc. Now we start preliminaries or basics of micronutrient, that is zinc. So today or now, we will discuss the symptoms of deficiency, what is important role of zinc in plant, and if deficiency is there, how to correct the deficiency or how to overcome the deficiency of zinc in crop production. So few terminology like zinc. It is a bluish white metal belonging to 12th group of the periodic table. Hope that you know classification of elements in periodic table. It occurs naturally as sphalerite. Sphalerite is the mineral, or it can be smithsonite, hemimorphite, and woodsite. and is extracted by roasting the oxide and reducing the carbon. So this is the method to obtain zinc from the ores. And you know these ores or minerals are sphalerite, smithsonite, hemimorphite, and woodsite. Next is zincated urea. It is a mixture of urea containing zinc as a micronutrient material or mixture of urea with zinc sulfate heptahydrate. It can be made either by dry mixing, bulk blending, or coating common fertilizers such as ammonium nitrate or urea. Suppose it is zincated urea. So commercially, at commercial scale, zincated urea is produced by coating zinc oxide. It is mostly zinc oxide which is coated onto urea to make zincated urea. And this zinc oxide contains about 81% zinc. How much? 81% zinc is there in zinc oxide. It is rich in zinc. If we take zinc sulfate monohydrate, it contains about 30-31% zinc. If we take zinc sulfate heptahydrate 7S2O, then it contains about 20.6 or 21% zinc. So that means this zinc oxide is very rich in zinc. Therefore, it is used for coating purpose also. Zinc oxide is cheaper also. It is cheaper than zinc sulfate. But zinc oxide cannot be used for foliar spray. If you want to go for foliar spray, then zinc sulfate is preferred. Mostly zinc sulfate heptahydrate. If it is zinc oxide, then it will make a kind of slurry, kind of suspension, you can say. It will not be dissolved in water. Zinc oxide cannot be dissolved in water. However, zinc sulfate can be dissolved in water. Therefore, zinc oxide cannot be used for foliar spray. It is used to coat the urea. Now, question comes that what should be the minimum level of zinc in zincated urea, and why zincated urea is required? Do you know about zincated urea? Means urea which has zinc is zincated urea, and it has become part of fertilizer control order FCO 1985. My dear students, you should be knowing that any fertilizer material which is to be sold in India or in country should be registered in fertilizer control order. If it is not registered in fertilizer control order, you will not get license to produce or to sell it in India. So zincated urea is there in the fertilizer control order 1985. So according to fertilizer control order, what should be the minimum content of zinc in zincated urea? Can you tell me what is the minimum level of zinc that is prescribed in fertilizer control order for zincated urea? Shubham, are you there? Dian?
I don't know, sir.
Who are you? You are?
Sir, Dion Mandal.
Okay. So any other? Subrata? Raj?
Don't know, sir.
Nobody knows. It is 2%. So 2% by weight, it should be zinc in zincated urea. Okay, so some companies are making zincated urea also. So what was the problem? Why we needed zincated urea? Now, one thing you can remember that zinc content should be at least 2% in zincated urea. Second point is why we needed zincated urea, because what happened that farmers were not using zinc. Farmers were not using zinc to the extent it was required. So what was suggested? Let us make zincated urea so that by default, if farmers buy urea, they will get zinc also, so that their soils will not get deficient in zinc. This is point number one. And point number two is that when farmers went to buy zinc sulfate, so actually it was spurious material. Most of the time market farmers are cheated by businessmen or by some retailers or by some shopkeepers. They mix some other material in the zinc sulfate and it is spurious. It is not true zinc sulfate. So problem was there. Therefore, to overcome this problem, let us add zinc into urea at the time of production of urea. But at the time of production of urea, when a company produces urea, it will add pure zinc. So therefore, farmers will get the zinc with urea and which is pure. That was another purpose. Because if farmers use spurious or duplicate kind of zinc sulfate in their soil or for foliar spray, it will not work. So money of farmer has gone waste in buying this zincated zinc sulfate. This is number one thing. Second thing, it was not the original or pure zinc sulfate. Therefore, zinc deficiency will continue in the soil and plants will be deficient in zinc because it is not original, it is not real zinc sulfate. So farmers was cheated in two ways. One, by paying money, he paid money, and second, he purchased nothing. He did not purchase zinc from that money and used in crop. So response will not be there because there was no zinc in the zinc sulfate. So therefore, zincated urea was suggested, and it is in the market, and some farmers, intelligent farmers, they use it. And why 2%? Because if you calculate the quantity of urea required in 1 hectare area, it will be almost equivalent to the quantity of zinc required by a hectare soil. So therefore, it was 2%. Now, zinc chelates are another source. Zinc chelate, it is expensive also, but more effective than zinc oxide for foliar spray. But concentration of zinc chelates should be less than the zinc sulfate. Zinc sulfate is normally 0.5%, but in case of zinc chelate, it may be 0.1, 0.2%. Zinc chelate is an inorganic complex in which a ligand like ethylene diamine tetraacetic acid. You can remember this complicated full form of EDTA, ethylene diamine tetraacetic acid. EDTA is bound to the zinc ion at more than 2 points so that the metal ion becomes part of the ring of atoms. The zinc EDTA complex is an example. So zinc EDTA can be used as a foliar spray. Zinc flits, sorry, this is frit, F-R-I-T-S. F-R-I-T-S, zinc frits. These are frits with zinc as the main micronutrient. Fusing salts of zinc with glass or sometimes with silica, fusing salt of zinc with glass or glass components from zinc frits. A frit, the meaning of frit is a ceramic composition that has been fused, quenched, and granulated. So this is some chemical thing, but you can remember that zinc frits are the source of zinc. Now, it is the major role of zinc is it is required by several enzymes like auxins in protein synthesis and seed production. It is also necessary for production of indole acetic acid, IAA. Zinc is believed to promote RNA synthesis, which in turn is needed for protein production. If you know different steps of protein synthesis, then you know that how it is accomplished. So for RNA synthesis, zinc is necessary. Therefore, if there is deficiency of zinc, then plant will suffer from, plant will get less protein production, less protein synthesis. Zinc deficiency in plants when it is less than 20 ppm or 20 milligram per kg dry matter. Interveinal yellowing on middle and or young leaves. So its deficiency symptoms mostly come on middle and young leaves, not on the older leaves. In some literature, you will find that it is written on the older leaves also. Very confusing also. So finally, I say that mostly young leaves and middle leaves are affected and lower leaves are not affected first. But if the deficiency continues, all the leaf, whole shoot will be affected. In rice, deficiency symptoms are chocolate brown, burned up rice plants. Or you can say in the beginning, there are small brownish spots on the plant, and these spots increase in size, and then whole leaf and whole plant can be covered, and there can be drying up of the plant. This is quite common in rice under puddle transplanted conditions where you keep the soils flooded or submerged. Under those conditions, you can have more zinc deficiency problem. So when you transplant the crop and then tilling occurs, so tilling is reduced. In this case, there may be death of the seedlings in rice if it is zinc deficiency. Means if your soils are deficient in zinc, the tilling will be greatly affected by zinc deficiency. And if it is in excess, more than 200 milligram is the critical level for toxicity, 200 or more than 200 ppm in dry matter. And excess zinc may cause iron deficiency in some plants. This is also important. Now, zinc deficiency symptoms in cereals, because the requirement of zinc is more in cereals and they are not very efficient user of zinc also. So mobility of zinc is low. Low mobility to younger tissues is depressed in zinc deficient soils. So therefore, younger tissues will show deficiency first and then middle area. Stunted plant growth, poor tilling, light green, yellow bleached spots, chlorotic bands on either side of the midrib in monocots like maize, brown rusty spots. This is important. Brown rusty spots on leaves in some crops, which is in acute zinc deficiency, as in rice, may cover the lower leaves. So it can cover the whole plant system when zinc is deficient. In cereals, internodes are short, flowering, fruiting, and maturity can be delayed. Shoots may die off, and leaves can fall prematurely. Zinc toxicity can result in reduction in root growth and leaf expansion followed by chlorosis. So ultimately, there has been seen that due to severe zinc deficiency, there is no grain filling, and the crop, the spikelets may remain empty. That is also a kind of symptom in rice and wheat. Zinc deficiency symptoms in rice, just now we have seen in cereal, same is case of rice, but some extra idea. Between 4 to weeks after transplanting, you can experience symptom of zinc deficiency between 2 to 4 weeks after transplanting. Dusty brown spots on upper leaves, blade size reduced or leaf size reduced, uneven plant growth, and patches of poorly established. So if you see that tilling is poor in patches, in some spots it is there, in some places it is not there, then you can ascertain yourself that it is the deficiency of zinc. Tilling decreases and can stop completely. Increased spikelet sterility. Chlorotic midribs near the leaf base of younger leaves. Leaves lose turgor and turn brown as brown blotches. Now you see the critical soil levels for occurrence of zinc deficiency. So actually in laboratory, there are many extractants that are used to extract the zinc from the soil and then estimate by atomic absorption spectrophotometry, AAS, atomic absorption spectrophotometer, is the machine used to measure or analyze zinc, iron, molybdenum, zinc, iron, manganese, copper. DTPA is the most common extractant, but some people in some laboratory also use other reagents to extract the zinc. And according to the extractant, the critical value has been fixed. Suppose if it is 1 normal ammonium acetate is used as an extractant, then it is 0.6 milligram zinc per kg soil is the critical value. If it is DTPA method, then it is 0.8 milligram zinc per kg is the critical level. These are important values for your objective kind of exam. 1 milligram zinc per kg of the soil weight is for 0.05 normal SCl. Then 1.5 mg zinc for EDTA methods and 2 milligram zinc for 0.1 normal SCl. So actually these differences are because of recovery of zinc, how much recovery can be made. So a method which is making more recovery of available zinc will have less critical value, means more efficient. So through this table or through this slide, you can learn 2 things. One is that what are the extractant that can be used to extract the zinc from the soil. So these are ammonium acetate, DTPA, and sulfuric acid, and EDTA. Second is their critical concentration, 0.6, 0.8, 1, and so on. Now in plant, normally, as I have told you, less than 20 ppm, 20 milligram is the critical level across the plant. So those were general values. Now this deficiency can be divided into 4 different parts. If it is less than 10 milligram per kg, it is definite zinc deficiency. 10 to 15 milligram per kg, very likely zinc deficiency. 15 to 20 milligram per kg, likely zinc deficiency. If it is more than 20 ppm, then it is I'm sorry, more than 20 ppm. I'm talking about the plant system. If it is more than 20 milligram per kg, then it is sufficient. So it is started with less than 10, definite zinc, 10 to 15, very likely, 15 to 20, likely, and more than 20. As you move down, you are increasing the levels of zinc in the plant system. Now, P and zinc and iron and zinc ratios are also important, as I discussed you in one system that was trees. So the ratio of P and zinc and iron and zinc in the shoot at tilling to panicle initiation stage are good indicator of zinc deficiency, because their ratios are also important. They interact in the soil, they also interact in the plant system. So various values should not exceed P is to zinc ratio 20 to 60 is to 1 in shoots at 6 weeks after planting. If value exceeds this, then the level of zinc will be lower in the plant system. Iron is to zinc 5 to 7 is to 1 in shoot at 6 weeks after transplant. You can see deficiency symptoms. It is in different crop, maybe cotton and maize, you can see deficiency symptoms. And then in rice, you can see this tilling. If you can see this picture, tilling is affected. Sparse population, plant population. And within the plant, you can see these dusty brown spots on the leaf in bands. They are also happening in bands, you can see. And then you can see complete drying of the leaves. So first picture is uneven field growth, plant is stunting. And number 2 is this one, tilling is reduced. And number 3, appearance of dusty brown spots on upper leaves. These kind of spots are dusty brown spots. Now see more deficiency symptoms. It is drying of leaves. You can see brown color. Here also zinc deficiency in rice and some other crops. Now, areas affected by zinc deficiency. What are the areas? So soils with coarse texture, high pH, high calcium carbonate, and low organic matter. Organic matter is a good source of zinc also. Acid, lees, sandy and sandy loam soils, light textures or coarse texture soils, high available phosphorus and manganese. So they precipitate the zinc, and zinc availability is reduced. Submerged or floodplain soils. So on flooding, zinc availability decreases. Soils irrigated with sodic waters means they will increase the pH. Therefore, you will get less zinc availability when topsoil is removed during leveling or lost through erosion. Reasons of zinc deficiency: a small amount of available zinc in the soil, because availability of zinc is very, very important. If a nutrient is there in the soil, but it is not in available form, then surely you will get deficiency. So there can be sufficient zinc in soil, but it is not in available form. It gets precipitated or it becomes part of other minerals. Planted varieties are susceptible to zinc deficiencies. So some crops and their varieties are susceptible to zinc deficiency. High pH, 7 or more, alkaline under anaerobic conditions. That is also there. Solubility of zinc decreased by 2 times or 2 orders for each unit increase in pH. Means if you increase the pH beyond say 6 or 6.5, then there will be sharp reduction in the availability of zinc. Precipitated as sparingly soluble zinc hydroxide when pH increases in acid soils following flooding. So flooding results in formation of zinc hydroxide. Formation of zinc phosphate following large use of P fertilizer. If in proportions to zinc, if you use more phosphatic fertilizer, then also you will get zinc deficiency. High phosphorus content in irrigation water can also reduce the zinc availability. High bicarbonate concentration because of reducing condition in calcareous soil with high organic matter content. So you will get more bicarbonate and hence the reduced availability of zinc. Formation of complexes between zinc and organic matter in soils with high pH and high organic matter. So that is the problem also, that here organic matter is not doing good thing. It is reducing the availability of zinc. So formation of complexes with zinc and organic matter in soils with high pH and high organic matter means when you apply organic matter in large quantities. Precipitation of zinc as zinc sulfide when pH decreases. Under acidic condition, zinc availability will be reduced due to formation of zinc sulfide. Based upon 15,000 trials on research station, zinc reported the average response of different group of crops. Means if you apply zinc, how much is the change in the yield? So there were several trials. Out of 15,000 trials, he averaged the data and see in cereals, 420 to 550 kg grain per hectare increased due to application of zinc. That is optimum level of zinc were used. Similarly, in pulses, oilseed fodder. This slide shows that zinc response is being obtained in almost all kind of crops in India. Now, zinc in soil. Total zinc in world soils ranges from 10 to 300 milligram per kg with an average 50 milligram per kg. In general, light sandy soils contain 31 to 61 milligram zinc, while heavy soils contain 35 to 75 milligram. So you can see one thing is common, that light texture soils contain less zinc and heavy texture soils contain more zinc. Total zinc in Indian soils is reported to be 47 ppm in antisols, 60 ppm in insectisols. So you can go through it. It shows the kind of soils and the zinc levels in them. Some have high, some have less. Most zinc is present in insoluble compounds and is unavailable to plants. So it is question of availability also. Only exchangeable zinc on clay minerals, or it may be on hydrous oxide of aluminum and iron and organic matter particle surfaces contribute to the soil solution zinc and becomes available to the crop plant. Means this exchangeable zinc is available and it can easily become part of soil solution. So we need to see what proportion of total zinc in soil is in exchangeable form. So exchangeable zinc in Indian soils varies from 0.1 to 2 milligram. So you can see 0.1 to 2 milligram. That means your 0.6 or 0.8. I'm sorry, just a minute. Hello. Hello. हाँ sir. हेलो, क्या बोल रहे हो आप? हेलो, 12 अक्टूबर ले लो, 12 अक्टूबर को ले लो, कर लो सर, ठीक है। हाँ वही धान पे रहेगा, धान का देखभाल कटाई वगैरह, धान की देखभाल। हाँ समझो, sorry. Only exchangeable zinc is, you can see the 0.1 to 2 milligram per kg. This is available zinc in soils. Zinc in soil solution at any time is very, very little and tends to be in equilibrium with exchangeable zinc. Barber reported that zinc in soil solution varies from 10 to the power minus 10 molar to 10 to the power minus 6 molar. Zinc deficiency is likely to occur in soils when soil solution zinc. See, it is soil solution zinc is 10 to the power minus 10 to 10 to the power minus 8 m. Lindsay name is quite famous. This Lindsay developed a method for estimation of zinc, and his method is common throughout the world. So you can remember this name Lindsay. Now, factors affecting zinc availability. So there are a number of factors like soil pH. The solubility of zinc decreases 100-fold for each unit increase in pH. Means if you go pH up, then pH is increased, then availability of zinc decreases. Rupa and Tomer from laboratory studies reported that the desorption of adsorbed P decreased with increasing pH and abruptly stopped at pH 7.5. So you can see beyond 7.5, you will get very little or no zinc is available for plants. Calcium carbonate is another factor. Number one was pH. Number two is calcium carbonate content in soil. So calcium carbonate increases soil pH, sorts zinc on its surface and may form insoluble calcium zincate. So as the calcium carbonate levels are high, zinc availability is reduced. So this would explain why zinc deficiency is more prevalent in calcareous soils, because calcareous soils contain a lot of calcium carbonate, which makes your calcium zincate. Therefore, availability decreases. Similarly, amount of sodium, calcium, and magnesium also influence the zinc availability. Both sodium and magnesium increase the soil pH and also compete with calcium for absorption sites on plants. Katyal Sharma reported reduced zinc uptake by plant in calcium and magnesium rich soils. So if you have more calcium, more magnesium, more sodium in soil, zinc availability decreases. Phosphate, if you have more phosphate in soil, high phosphorus will reduce the zinc availability. And particularly in acidic conditions, if conditions are too acidic where phosphorus availability is there, increased phosphorus availability is there, so it will make insoluble zinc phosphate. So therefore, zinc availability will be affected. The root colonization, just leave it. I will discuss later the role of mycorrhiza in phosphorus and zinc uptake, but they are very, very important. If you have sufficient mycorrhizal growth on the roots, then it increases availability of both zinc as well as phosphorus. Soil moisture is also important. Adequate moisture in soil is necessary for zinc uptake. This is why zinc deficiency is more pronounced in dry soils or dry regions. So some moisture has to be there. Gao 2006 reported that zinc concentration is in rice leaves at tilling as well as physiological maturity was lower under alternate wetting and drying condition as compared to continuous flooding. So there are different kind of results. In acid soils, now this is important because sometimes you may flood your soils, particularly in rice. So in acid soils, zinc deficiency may be attributed to increased pH under reducing condition. If you put water into the soil in acid soils, it raises the pH of the acidic soils, and subsequently it is precipitated as franklinite ZnFe2O4 or sphalerite zinc sulfide. So therefore, availability of zinc will decrease. Decreasing pH in submerged soils. If your soils are calcareous also, then the pH will decrease and it will increase the zinc availability. So alkaline soils will be benefited. However, with high pH and poor aeration, potential zinc deficiency is aggravated. And now question comes, you can know a little more about it. Water-soluble zinc availability decreases in flooded soils. The decreased zinc concentration is due to, number one, precipitation of zinc hydroxide as a result of increased pH after flooding. Number two, precipitation of zinc carbonate due to carbon dioxide accumulation resulting from organic matter decomposition. Precipitation of zinc sulfide under very reduced conditions. High manganese concentration antagonize zinc absorption and translocation. You should remember these points when you defend that water availability. As you increase the water availability in rice soils, zinc availability decreases. Root system is also important. If your roots inefficient plants or crops that can use zinc more efficiently, they have better root system for absorption and uptake of zinc. And we have zinc use efficient genotypes also. So roots play a greater part in translocation of zinc from, so just you can read, this is very important point because time is limited, but I will share these slides. So whatever I am not discussing here, please read from the slide. But these, believe me, these are all very important points. You should see them. What can be done for correction of zinc deficiency? Selection of zinc efficient varieties and crops. In nursery, broadcast zinc sulfate in nursery seedbed. And in crop establishment, for example, rice, in case of rice, dip the seedling or pre-soaked seeds in a 2 to 4% zinc oxide suspension. Soil application is most efficient. The rate may vary from 25 to 60 kg per hectare, but normal rate are 20 to 25 kg. Foliar spray 0.5 to 1% zinc sulfate, and it should be neutralized with half the quantity of lime. And you can see the variety have been developed, high zinc rice variety, DRR Dhan 45. Thank you. We can go to the